All right, hey guys. So this is video number 4 for me. I've been struggling kind of with some technology today, so I'm going to try to buzz through this thing just as fast as possible. I'm going to start by recapping here basically what we did for all of our Stoic problems, and then go through on the final one. It's actually a really quick setup, so let's go ahead and take a look at this. So the first step of any stoichiometry problem is one, to understand what it is. You're not doing it just to get an answer, okay? You want to show your process. And the reason why you show your process is so that your colleagues and yourself can go back to your paper, go back to whatever it is you did, and know that you did it correctly or find an error. Okay, and how do you do that? Well, one, you have to come up with a consistent way of doing it. That's why I like doing these little T-bar things, okay? They're an easy way of showing your math, okay? And your math is usually where most people mess up, okay? So find a process, okay? Make sure that you commit to writing out things in a certain way. And as you do hundreds and hundreds and hundreds of problems, you start to ingrain these habits, okay? I can't force you to do that because I'm not going to hand you hundreds of worksheets. I wouldn't do it even if we were in class. But what you can do is you can think about the point of doing these problems. And it's not to just get an answer, it's to prove that you can do it. Okay? So if my goal was to prove to you that I knew the answer to a problem, that's going to change the way I outline it. I might even brag, I might even embellish and be super neat, right? Okay, so that's the point of doing these problems. Go ahead and write them out really neatly. Go ahead and write them out and write little notes on what you're doing, okay? Try to show off that you know exactly how to solve the problem, because that's going to help you later, and that's going to help your boss see that you're competent someday, okay? Really important thing to do. So let's start out. So first you balance the equation. After you balance the equation, you find the molar mass. What would you do? Well, you find a periodic table and you find the element symbols here, you find the weight of them, and you add them all up. So that's basically how you do that. So go ahead and click like something like this. So we go periodic table, huzzah. How much does carbon weigh? 12.01. All right, we can see that right there. Cool, neat. All right, so that's how we do that. Okay, so let me recap what we did before. What we did before, and we have this nice little outline here, is we went from the grams of water to the moles of water. And how do we do that? Well, we take 2.46 and we divide it by 18.01, which is going to be the weight of two hydrogens, which is 1.01 times 2, plus the weight of oxygen, which is 15.99. Okay, and if you don't believe me, you can check my work. I guarantee you it's right. Those numbers are ingrained in my memory forever. Okay, so next you have your moles of water, and now we have to do a ratio, which is what we did yesterday, a ratio of moles to moles. And what do? Well, you always divide by what you have to find what you want, okay? So I know there's a 10-to-2 ratio. Well, if I have 10 of these, does that mean I multiply it? No, because you divide by what you have. We're saying for every 10 of these, we have 2 of these. So divide by 10. So 10 H2O, 1.37 moles of H2O. The H2Os cancel, and now we can have a totally different unit, which is butane. Okay, so divide by 10, multiply by 2. We know we have 0.0274 moles of C4H10, which is butane. All right, I think it's butane. Yeah, it's butane. All right, so now that we're there, now that we have our moles, how do we get back to grams? Well, we have to, again, calculate out this number. So C4, C times 12.01, okay? And if we do that, we have to add that number, 12.01 times 4, plus 10 times 1.01, okay? And we end up getting 58.14. I would show you the entire process for this, but it seems that after like 6 minutes, this video just cuts right out. So I'm going to try to keep it short and keep it sweet. Okay, so we take our molar value that we got in this problem above, okay, and we multiply it by 58.14 grams per mole, okay, and the G's on top, our M's cancel, and we're left with grams, and that's grams of butane, okay, and I could write out here butane. I'm just going to put a B here because it's very hard for me to write using the mouse legibly, okay? So, just to recap what we did, we went through and we did grams to moles. We did moles to moles using the molar ratio, which was for every 10 of these, we got 2 of these. So divide by 10, multiply by 2. Divide what you have to get what you want. Okay, that's a good way of remembering it. Okay, and finally we get grams. How do we convert moles to grams? Well, we multiply it to get the answer. All right. If anybody has any questions, you can hit me up on my email, whatever. I would love to talk to you guys, love to chat with you. You can always show up to the Zoom meetings, which will occur at 10 o'clock every Tuesday and Thursday, I believe. So let me know if you want to set up one individually. I'd totally be game for that. If you want to call and walk through a problem, I would totally be happy to do that. If you want to Google Classroom or Google Chat or do whatever and you got a chemistry problem, I'm more than happy to help you guys out. Hope you guys are doing well. I hope this makes sense to you. What we're going to be doing this next week is we're going to be moving into stoichiometry with cookies. All right, so I'm going to have a fun little lab for you guys, and it'll be like the last little recap. So if you guys just make cookies and see how all that works. It's all kind of a similar process, right? You have what you're given, you have to figure out what you need, and that's all stoichiometry. It's just applied, so it's kind of disguised and seems a little bit easier, but you're still using the same process behind it. So if I give you like 2 cups of flour or something like that, and you want to figure out how many cookies you can make out of that, you're doing stoichiometry. All right, Mr. Ziema and I talked about this for at least an hour. Kind of fun. So it's basically using chemistry in everyday occurrences. And it's a fun applied way to do it. I'm going to share the lab with you guys. And if you want to take pictures and go ahead and post them on there, go ahead. I would really love to see that. So hope you guys are doing well. Hope you'll enjoy this next lab coming up, and have a great weekend.